Today I'm going to be talking about iOS security. Today I'm going to demonstrate just how vulnerable our internet identities can be and the way with which they can be stolen. I hope I can see my screen. So with no further ado, behind the walls, penetrating a secure iOS system. So before I do so, then let me briefly introduce myself. So I am Cyril, I'm working for Porsche, as you've heard. We are working on this My Porsche app, and since the app is talking directly to the vehicle, security is very important to us, and that's why I started roughly 5 years ago digging around what's possible, working with a lot of penetration testers and trying to hack things on jailbroken devices, and that got me actually into this journey. We are roughly 30 teams working on this app, so we are having like a highly modularized code base, so it's also a lot of challenges there when it comes to engineering. Around 80 iOS developers are contributing to this app on a daily basis. While you might be during your lunch break playing ping pong or kicker, so this is what we usually do around Stuttgart. You might see here 3 Porsches, but what I see actually are my test devices. Okay. So you should be now awake. So before we actually go and do something, then we need to have a target. So our today's target is Dviba. Dviba is damn vulnerable banking app. Very solid business. I have many customers. It's my app developed purposely for reverse engineering challenges. So maybe before I introduce you Dviba, which runs here, let me tell you a little bit about my arsenal and about my lab here. So here on stage with me is my iOS 16 jailbroken iPhone 8, together with my iPhone 16 Pro running iOS 26, and my MacBook. And I usually have a statue of Arnold Schwarzenegger, but that's currently not with me. Okay, so let me show you Dviba. So, okay. And Dviba is crashing on start. So you can probably imagine that, or if you think about what would be the worst nightmare of a developer, then this is it. So you have an app which I should showcase in 40 minutes, and it crashes on start. Okay, not good. So I have 2 options. Either I'm going to go home crying, or I'm going to go to action. So let's go to action. So here on the left side, what I can do now is to create iProxy. I'm going to use 2 ports. So those are 2222 and 6s. I need to create one on iProxy on 6s for later on for debugging. And the first thing I'm actually interested in is what's happening in the runtime. For that, I'm going to use iDevice syslog with the process. And now if I tap Dviba, then this gives me a full log from the system. Essentially the same thing as if you would be using console and pipe the console to the device. So here, not many things interesting. But here at the very last part, you can see fatal error found jailbroken device. So this is actually not crashing because it is a developer problem or like array out of index, whatever. It crashes because it's a feature and it should crash on a jailbroken device. Okay, so is there something we can do about it? The question is, let's find out. So let me SSH on my device. And now what I'm going to do, because like usually I would directly start debug server, connect my local debug server from the device to my Mac, but I can't do that because I can't even access the app because it doesn't run. So we have to first patch that. In order to do that on my device, we can see who am I. I am root. Pretty cool, by the way. I can now I can show you my LLDB init, and here you can see I created hooks for the LLDB. So now if I do LLDB wait for and launch Dviba again, then you can see then it stopped in my debugger. And this is actually running on the device. Right now, I have LLDB installed on the device. I directly attach debugger to the app, and this stopped at the very first point where the app launches. So here we are at the point DYLD, so that means that dynamic libraries are starting to load into the process. Very first thing that comes into like after the app launches. So this is not interesting to me, so let's continue the process execution. And now we should get into UI application main, hopefully. There we are. Now if we continue again and again, then we are here on the runtime error, fatal error, found jailbroken device. And this is exactly the point that crashes. So now I'm actually not interested in exactly what's happening in here, but I need to find a place what's happening before. So here you can see this is my backtrace from the stack. So this is the last symbol that actually comes from Dviba. So from our process that we are reverse engineering, and this is coming from the native Swift core library. That's essentially where the fatal error is implemented. So this symbol is the last place which is called from my app. So let's see. We're gonna have to try to hook into that procedure and have a look what's happening in there. So now, like, I have to do process detach, and that's gonna kill the app. Now we have to do the same gymnastics again. So launching Dviba again, we are in the same breakpoint. So the ilibs are loading. Now continuing the process execution, we should get now into the UI application main, and there we are. And as next, we are in the symbol. I forgot to tell you, but that's part of the LLDB init as well. And this is the symbol that I'm now the most interested in, right? So now I can disassemble the symbol, and I'm sorry to educate you against your will with assembly, but this is the critical part to understand a little bit. So we have here the instructions. To make it brief, like none of this is actually of my interest right now. We have to find the place where we are redirecting to the fatal error. And that's going to be somewhere around here. And you can see those two checks. So there is iOS security suite, am I jailbroken? So that's the first check. You can see TBNZ, so that's test bit branch if non-zero. And you can see here W0, that's in 64-bit architecture X0 register, and it compares to 00, which is 0. And if this doesn't match, then it hops onto the 874 address, 8874. So now bear with me, 8874 should be somewhere here. 8874 found jailbroken device is here. So that's what it does. So if this is true, which is checked here, it's going to jump onto the fatal error. So that's the first check. The second one is, am I debugged? So it also checks if debugger is attached. And that's the second check, which hops on 8B8. And that's something that we have to take care of as well. So what I'm going to do now is I'm going to set a breakpoint on this address, so on the test bit or TBNZ. So we're going to do breakpoint set on address. Now we're going to continue the process execution. Now we are at that point. So if we disassemble the thread again, then you can see that we are here. We already branched and came back from the mi jailbroken function. And now we have to have a look what's happening. So our X0 registers, as we would expect, are having true or 1. And they are being compared to the X0, 0, which is 0. And that obviously doesn't match. And there we jump onto the fatal error. So what I can do now in the runtime is to directly directly override the registers. So we're going to do registers write X00. Now I'm going to double check. And our registers are now 0. So this should pass. Now, if we have a look again, we need to also check for the second iOS security suite, am I debugged, which is on this address. So I'm going to set a breakpoint there as well. OK, and now I'm going to do next step. Now you can see that we already bypassed the first instruction. We didn't hop onto the fatal error. We are in the iOS security suite "Am I debugged?" So that's pretty cool. Now we have to take care of this call. So if I do next one, then here is tbnz again. So this is now checking for "Am I debugged?" And since I have my debugger attached, then I am debugged. Now if we read the registers, then you can see again it's again 1, as we would expect. Now I can again registers write x00, double check. So we overwrote those registers as well. And now if I continue the process execution, then the app loaded. Okay, this is pretty cool, but it's not all. So now we actually are running the app on the jailbroken device. We bypassed it in memory. But what I can do now is to do, now I have to be very careful, else I would have to do it again. So I have to remove the debugger, so I will do process detach. So we are detached, and now if I go to my desktop and binary dump, now what I can do, because, or let's first do it. Now we need to activate my my environment for a reverse engineering, and now we have to do Python binary dump. And this is dumping the dvibah from memory. So when you download an app from the App Store, then it has the RM policy. So Apple encrypts the binary partially only. That's what you're going to see in a bit. And now, since I dumped the binary from memory, I have everything at my disposal, and I can fully work with the binary, and it's completely unencrypted. You can also see here, together with the main process, dvibah was also transferred to Trustkit and iOS Security Suite. So we saw that iOS Security Suite provides us the functionality to check for iOS, am I debugged and am I jailbroken? So that's implemented there. And Trustkit is recommended by OWASP for or the Open Web Mobile Security Standards to provide SSL pinning. So we're going to also have a look what we can do with that information that now we know that Trustkit is included in the runtime as well. Okay, so now we have the binary here. Now I can actually move dvibah IPA to dvibah zip, then we can unzip. And now I have here the payload, open payload. And here we have the dvibah dumped from memory, fully decrypted. So I need to do one more thing. And now if I go back to my jailbroken device, and I'm going to have a look at, no, that's not it. That's here. So we can kill this. And now I have to find where dvibah is actually installed from the App Store. And this is the original location, or from the test flight, sorry. This is original location. So now I have to also have the original binary that I'm going to be working with. So that's SCP, and we're going to SCP the binary in its encrypted form to our desktop, or mine. So that's that. Now if you go to desktop, I'm gonna move this to dvibah, and I'm gonna like now we have dvibah, and we're gonna do a backup of it as well, which we're gonna later on be reverse engineering. Okay, super cool. So now we have the binaries. We have the fully dumped binary from memory, so we can have a look what's inside. So that's here inside the payload. So show package contents. Here you can see a few things. At this point, I'm interested in two things. So here is my binary decrypted. Here is Google Service Info plist, completely decrypted. That's like on Google's. Here you can see that the app has Firebase database. So that's something that we're going to explore, because there has been an update of the app, and they shipped a new feature, which is called Chat with Agent. So we're going to have a look at that. And this is a share with a friend view, which is like also included within the application. and it's offline web view that's then loaded, or now we can only assume, but it's an offline view that's then loaded into the process, and we're gonna also have a look around that. Okay, cool. So now let me open Hopper. And if I go and dump Dviba onto Hopper, then it will load the binary. And now you can see that we can see the full procedures. You probably won't be able, yeah, okay, I can zoom in a little bit. So this is fully decrypted binary I can now fully work with, so that's pretty cool. And what I now am interested in is the IS security suite. So if you have a look, so here is the MI debugged. So this is the symbol. Now we have to find where it's referenced from, and this is the stub that actually branches into a dynamic framework. So we have to still have a look where this is implemented. And here we see the MI jailbroken and MI debugged in the binary. So that's what we saw in the runtime as well. And now we're gonna try to do something about this. So this is out of my interest right now. So I'm gonna go back to my terminal, and now let's go to Dviba Re. And we're gonna open Radar 2. So Radar is also a command line disassembler. You can see now that I'm working with the encrypted binary, so not every data are available to me. Now, if I analyze the binary, so this is going to be a short time, then it should analyze all the symbols. I should see them in the same way as they are in the Hopper. Hopper is like really go-to disassembler on a Mac, but Radar is a little bit more advanced, I think, and you can work with it in the terminal, and that's super cool. People in Starbucks love it. So here we are. So this is loaded in the Radar, and what I have to do is to find this also in the Radar. So what I'm going to do, I am actually looking for this address. Yes. So actually, security suite MI debugged. So we have to find that address in Radar. We have to disassemble the thread here as well. Here we have the fatal error, found jailbroken device. This is the MI debugged, MI jailbroken, and this is the TBNZ, which we bypassed in the runtime, and we now have to bypass it here as well. So here, just to double check that I'm on that instruction, so PD1, so this is TBNZ, and now I can actually override the instruction with NOP. If I do PD1 again, then it's NOPed. NOP is the same, it is an instruction of the same size as the TBNZ is, and NOP essentially does exactly nothing. So there will be no comparison. The program execution will just continue. So this would be the first step. The second, I have to also bypass the MI debugged, which is checked here. So we have to go and seek that address. Again, we're going to do PD1 to make sure. TBNZ, now I can do and override the instruction. So now I can double check, and now I can double check the whole thread. And here, if we go on that point, then here we can see that we have the branch link that's going to written through. It's NOP, so no comparison. MI debugged, same, also NOP, also no comparison. So we should hopefully be good on this side. So that's pretty good. The second, I need to actually go, because we saw Trustkit, and I've been working with Trustkit ever since I was an iOS developer, which is like probably almost 12 years. Now, if I do TSK, because like I also compiled Trustkit and had a look what kind of symbols it produces, we have here KTSK spin domains. And if we go and have a look what's implemented underneath, then here you can see pinned domains is essentially the configuration of Trustkit. And somewhere down below in assembly, we're going to see the URL that's being pinned. And this is the URL, Dviba iOS reverse engineering. And this is the place. Actually, I should have the address there. Okay, I'm not sure. Okay, one sec, quick thing. So we don't need this. I can just double check that I am actually here, binary dump, payload, show package contents. And now if I open Hopper, essentially what I'm trying to find out is where the URL is, in the URL from Trustkit is, which I should be able to get a full address to in memory, which I should be able to also bypass. So if I go here, yeah, perfect. Yeah, okay, it's too big and I missed it because it's on the left side. So yeah, don't make your screens too big. Okay, so this is the address where the Viba URL is stored in the binary, and now we can go there. We can have a look what's inside, and this is the place where the Viba is. So this is in data part of the binary, and this is being pinned. And now I thought quite a while what would be the most elegant way to actually go around it. And what I can do is instead of stripping the whole thing from the binary, I can just override the URL, right? It's still going to be pinned, but it's going to pin a different URL. So the original URL will just go through and opening will be in place. So this was the most elegant way I found to bypass SSL pinning on this level. So now I can quit Radar. So we've patched the instructions and we've patched also SSL pinning. And now if I go back, let's go to the desktop. Now I can do Radif. And Radif essentially does git diff between binaries. And here you can see that we have TB and Z patched to NOP. Then we have the second one patched to NOP. And then we have 64, which is ASCII representation of D from Viba, to 78, which is ASCII representation of X. So that's pretty cool. So now we have our reverse engineered library. And what I can do now is to go to Xcode, and we're going to sideload the binary to my device. So now I have to kill this app here, and we're going to go to the desktop, get the Viba array. We need a reverse engineered binary, and grab the Viba to the device. Yes. Then let's wait until it gets installed. So it's installing now. And now if I open Viba, then it loaded. And I no longer have to bypass it in the runtime. I can just like work with Viba now fully and use the app at my disposal. So that's pretty cool. A short applause would be nice. Thank you. In the meantime, I'm typing my password. So Viba, super secure. You can't see my password now. And login. And now this is Viba. And let me introduce you to Viba a little bit. So this is list of my items. So I went to Rewe, went to Tesco, then went to shop at Stuttgart, bought a new 911. Typical Monday. So yeah, that would be my list here. And the feature that we are interested in is the new feature called chat support. So let's directly have a look at it. We saw in Hopper, and we saw the info P list. Firebase database is included in the binary, so that's something good to know. And now what I'm going to do is when I go to my LLDB here, and we have to start at our debug server. And those are the 6s. That's where it comes to play. And now I can create LDB session on my remote, on my desktop. And we're going to do platform select remote iOS, process connect. And we are connecting remotely to the device. And we are in the runtime now remotely connected and debugging the application. So now I'm in Mach message trap. That's fine. what I'm interested in, like this took me also quite some time, meaning it was more than 1 or 2 prompts. How would you now get the token from Firebase, right? Because now, like, my best assumption is that this is Firebase, and now I can actually poke around Firebase. I can do I can use Objective-C runtime here and its class from string to get current user, to get the user ID. So we now know that the user is there. We can also print the whole user object from the runtime. This is only because I am able to use the Objective-C runtime. So that's pretty cool. We got the object as well. And now I can do, I didn't find any way to get the access token directly. It's not in the keychain. It's stored somewhere magic. But I can get the refresh token. So let's grab the refresh token. And with the refresh token, what you can do is you can get the refresh token. Now bear with me. This is going to be copy pasting. So refresh token, paste, enter. OK. And it directly stored it as variable in the terminal. And we got the token here. So we exchange the refresh token to access token. And now the second thing I need to know is what kind of endpoints the database offers, right? So the best thing to use is to have a look at developer logs, because every single developer would log which endpoint is subscribed to Firebase. So those are two paths that are printed to us. Similarly, I would be also able to hook into the runtime of the Firebase itself and observe via registers where the paths are being observed. So let's have a look at chats. So if I go here, then chats, then we have, what are you doing? Chats, and this is not. So this is my ID, and those are the chats. So this is exactly what's inside the app, as we would expect. And what I can also do is to have a look if I use a different ID, which I created before. I could look if I would query like some other user's data, which I can't, so permissions denied, so that's correct, that's good. Now the second endpoint were users' data. And first I can have a look if users' data are public endpoint, but it's not, it shouldn't be, and it's restricted, so that's all fine. So like nothing to find here, but what if I actually put the token to the user's data? So now, like you can see that that we receive the user's data with the access token of the user, and this is just like one-liner in Firebase, so no biggie if you forget it. But now we actually found something. So this is not something like super vulnerable, but like it's a solid data leak for the app, and we have like full email addresses. And we should also somewhere have my favorite user, which is Arnold Schwarzenegger. Yeah, we should then, oh no, what are you doing? Yeah, so Arnold is here. And we have his email address, and that's important. Okay. So we found one issue in the Firebase rules. So one unrestricted endpoint, which works with valid login from a user. Okay, but there is something more we can do. And now I don't have enough time to disclose everything fully, but you're just gonna have to bear with me. We're gonna go to LLDB. We're gonna continue the process execution. Now I am back in my app, and let's have a look on the feature that I described in the beginning. So share with a friend. So share with a friend is a view. Like as usual, you don't have enough time, you will hack it, you will add like embedded view into your iOS. No one really cares about it. It's embedded in the device. What could go wrong, right? Right. So first thing to tell is that this web view is actually vulnerable to injection, and you can inject JavaScript into it. Now what I can do, I actually wanted to show you something like this, probably. Yeah, so from the JavaScript inside of the view, I would be able to have a look what's inside because it's JavaScript. And here you can see it like, okay, the magic behind it is that you can't easily override the triggers of JavaScript, but you can load external image into the HTML. And an image can have like onload function. And what this does is that you have onload, which will call get token because the web view talks to the main app via IPC. And if I press it in, then we injected the image. And what's like the most brilliant piece of this JavaScript is that I'm sending the token from the app via the image parameters because you can't do anything. Like WK Web View is super secure. The thing is that here the vulnerability is that there is just inner HTML, which, by the way, if we go here, so this is my sniffing server. So that's like what serves the 8.jpg, which serves the image of Arnold. And here is the token that's grabbed from the user. The way how it works is that the web view must be authenticated so that that we know what user actually created the referral program. So you're gonna grab the token from the app via IPC. Then you're gonna get it back into the web view, store it in the web view, and then send the request or authenticated request for the user from the web view via your app. So that's essentially a normal flow implemented in a very bad way. But like if you don't have time, this is what you would do definitely. And like this is a real world scenario. So if you have a look, what's the best way to inject something into JavaScript? So that's this. And this is exactly what the app does. So there is no validation of the input. Everything can be parsed in. Everything is taken, loaded into the HTML. Real life example, our junior developer created this, and then I told him probably not a good idea. Okay, but there is something more. So let's have a look at our binary again. And SwiftUI experts could tell me, but I think it's can open URL. Yeah, you can see it here. And this means that the app actually is handling deep links. And lucky for us, we can also send a deep link with the share with a friend feature. So if you go back here on the home screen, and let me show you the sniffer. And if I go back to the example, then I can have a look here. And if this is, by the way, the same script, but parsed in via the deep link. And this is URL encoded JavaScript because iOS doesn't validate anything. Then you can load the view and we receive the token here. I'm hiding the image, obviously, so Arnold doesn't see anything. I send the token to my server, and now I could start like scraping the API of the app server side. But that wouldn't be me because I'm a mobile developer. Then let's have a look what we can do. So first thing, like we have to craft our attack. So let's have a look and let's go into email. No, go away. And now we need to message Arnold. Hey, €5 for free. So who wouldn't want €5? So now if I go back to my presentation, then this is the payload that we have to parse in. And this is click me. And now we're gonna just link at the link, send it, press send. And now we're gonna wait for Arnold to receive the email. And it just so happens that I have Arnold's phone with me on the stage. And if I open my email to click me, then you can see that I received Arnold's token. And this is super awesome. So now, from the mobile point of view, like there could be many validations, device spoofing, all sorts of things. But we are here in the runtime already. So we are still, we need to, this is we need to process interrupt. And now like we are in the runtime again, and I first have to import a few things into the runtime. So we're gonna import foundation, we're gonna import Objective-C, and we're gonna import, I think I will need UIKit just as well, yeah. And now I can write an expression. Yeah, I did workshop, there are too many commands. Yeah, okay, so expression, we're gonna actually inject it in Swift. And this is my my keychain injection. This is the token of Arnold. You can see it here. And again, like keychain is like written in C and Objective-C. And now I can fully disassemble keychain or like figure it out the queries that are needed for my keychain. I am in the runtime of the app, so I can also reverse engineer it properly. And I could also trace the keychain to figure it out, what it does on the background. So now I continue the process execution. Now, as every sane developer would do, you would probably cache the user's token. So we're going to do process detach. Now I'm going to go back. Let's kill the app, and let's try to launch it again. And when Dviba launches, then you can already see we are under a different account. So we have like here Protein Shake, Gym, also shopping at Stuttgart. And you can see that we are under an account of Arnold Schwarzenegger, which is a hardcore killer. So I'm not sure if that was a good idea to do. But I am already in this gem, so let's try to rob him at least for some money. And I can't do it because there is a second level validation before the feature or exactly on the feature, which tells me jailbroken device detected, but it could be also spoofing or anything else. Like against spoofing, it could be also device attestation from Apple or similarly also on Google. So that's pretty annoying, but what I can do obviously is to start my debug server on the device again. Then let's go to the runtime again. So we're gonna continue here. We're gonna kill this. I'm gonna go LDB again, platform select, process connect. Okay. And now I will need a few things again. So we are actually working again with the Objective-C. And I don't have enough time. You're going to have to trust me. So this symbol is purposely there for the demonstration to show you that this wouldn't be possible to find within the binary itself. You have to, or within the encrypted binary. This symbol I was able to find only in the decrypted binary. So now if I do hopper again, is jailbroken, then we got this Objective-C check for the as jailbroken. And this is what we have to bypass. We can see it's a static Objective-C function starting at this address. So I can actually again go here, and we're gonna do import, but we need to be under Objective-C context now. Import Objective-C. We're gonna need foundation again. I better import UIKit just to be sure. And now no. Wait. Now I have to actually, what I want to show you is how to do it in the runtime and how to do runtime swizzling. So this is again a function that returns true or false on is jailbroken. So what I can do is to inject my own function, which is called always false. So we're gonna inject into the runtime our own code, always false. Now I can call always false, which returns nil, aka false. And now I need the address of always false, which is this. And now I can go on the expression. And this is like Objective-C runtime swizzling. And this is actually an Objective-C++. So if you, I don't know why, but the Objective-C itself stopped working in the recent updates, and it bugs me quite deeply. It went through. So now if I go and continue the process execution, and now if I go again here, then I'm no longer facing the dialog, and I can fully work with this view. And obviously, I'm gonna rob Arnold for $1,000. And that's how I've done it. Okay. Pretty cool, isn't it? I'm gonna get killed, but it was 100% worth it. So a brief summary, like I have 20 seconds, so you're gonna do it at home. But can this be in a secure way? Absolutely. So for example, for the token exchange for the web view, you shouldn't have like token with so many permissions. You would have to do some token refresh which has permissions to do the referral only. That would be, for example, a way to do it. However, that's insane amount of work. Permissions are like difficult, but like most importantly, tokens expire. You have to have token refresh mechanism. It's passed into a separate context, which is the WK web view. It's a piece of work to do it properly, but it should be done properly. So was this two-staged? It was. But the issue that you saw with Firebase, there were over 500,000 apps found with the same issue. It was back in 2022 where Firebase was at its peak, and some of those apps had like 100 plus millions of downloads. Therefore, like major applications were facing this issue. There were exposed names, password, credit cards, all sorts of things. I was very, very low because I exposed only the email addresses so that I could grab them and basically create a phishing attack. In the real world scenario, you would probably buy a database of leaked users from dark web. And if you would find any of these vulnerabilities, you would then start phishing attacks. There are many apps using those approaches. Many apps are doing this. This web view, like it's not available in Czech, but in Germany there is Amazon, and they have also like this sort of hybrid mode implemented. And yeah, so be careful of like what you are clicking on in your phone, because even if it is embedded in the phone, it doesn't really mean it's super secure. I, in 45 minutes, was able to demonstrate it, how you can breach such application. So what you also saw, like this is last slide. So OWASP standards are well known. That was the Trust Kit. Big players are implementing it on their own. Like when I was looking around on HackerOne for big players, then everything was custom made. They didn't use the Trust Kit and didn't use the OWASP standards. Was everything implemented from scratch. That would take much harder for me to figure it out and reverse engineer. However, the amount of time spent, at some point, I would probably be able to do it. And yeah, mobile security is just as important. Now, most of you would come to me and tell me, yeah, hey, iOS 16, that's lame. Well, the same I was able to do on the iOS 18, so that's one device before. With rootless jailbreak, everything works the same. I have the iPad here as well, so even the most modern, or like one before the last one, is available to do those things. I use the reverse engineering techniques on my jailbroken device to find a vulnerability on the app itself, which I could then exploit remotely via the deep link and target normal devices, obviously. Yeah, I accomplished many things, but we don't have time. Closing words, like every single pen tester would find this issue, probably even juniors. So do pen tests, it's very important. If you like what you saw, I'm also offering reverse engineering trainings, which I did yesterday. I can make it tailor-made for your company. Or you can also support me by downloading Pets Therapy. And that's probably it. If you want lifetime subscription for pets, just shoot me a DM via Slack, and you can have Llama or some other pets running on your displays. That was it, and thank you very much.
Thank you very much, Cyril.
Yeah,
it was a pleasure. You
Yeah.
know, like I really love these live sessions. So
Yeah.
I can only imagine how much time you actually spend preparing such. So
You can't. It's
No.
beyond imagination.
so perfect. And we have two questions actually. One, can they trace the hack back to you when you do the stuff like this?
Probably. Like there is a server involved, so you can probably get to the server, and via the server and URL, you would find out who is behind it, and that's how it's usually done. But there are like many techniques how to prevent also being found so quickly. But essentially, like how police work, they would take down the server, take down the URLs, and that would stop the attack for sure.
Yeah, and the second question is related to the point you mentioned on the last slide, the combination of devices which are out there, which can be jailbroken, is actually shrinking. Does it somehow affect your job, or does it have also impact on attackers, making their life more difficult?
Um, So I'm a software engineer, so this is fun. Like I don't do this like professionally. Like I'm not a pen tester, and I'm not a security researcher. But I didn't like how pen testers were ignorant to those topics, and I wanted to find out how it works. So I wanted to demonstrate it to you as well. Um, Indeed, like if you look at like iOS 12 and 13, it was pretty much opened. Like you have so many jailbreaks, you could do most of the things there. I have like 5 iPhone 5s, which I have actually in my drawer, all jailbroken, and I had lots of fun with them. Nowadays, it's much harder, but you can still get iPad 7th generation and jailbreak iOS 18, so that's super awesome. And you can, on iOS 26, there are also ways, not jailbreaks, like not official jailbreaks, but certainly there are agencies that have some route to that. And those you can use in sort of unprotected way when you have the, I don't want to say the name, but there is a service that allows you to run unprotected on the device. It's used for security research.
Yeah, and maybe just to add on this, we can see many 0 days coming because of AI. So maybe there will be new combinations of jailbroken devices thanks to AI.
Yeah, absolutely.
Right.
That's what we see every single day now.